So in this video, we're going to look at some examples of estimating a number squared. So here in our first example, we've got 4.5 squared. Now we would expect that to be between 4 squared, which is 16, and 5 squared, which is 25. Okay, so somewhere between 16 and 25. 4.5 is halfway between 4 and 5. So if I find the average of 16 and 25, so by adding them together and dividing by 2, that finds me the midpoint. 16 and 25 is 41. Divided by 2 is 20.5. Now, from the previous video, we saw that our estimates here are always overestimates. So 4.5 squared would probably be around about 20. So I'm going to use the approximately equal to sign here, 20. So it's like an equal sign, but like two wavy lines, kind of like almost equal to. You can kind of think of it like that. So our next example is 4.1 squared, which again is going to be somewhere between 16 and 25. But how much? How far along is it? So what I could use is that interpolation method that I showed in the previous video and think, well, the gap between 25 and 16, essentially you could do this for the 4.5 squared as well. Okay, we look at the gap, 25 to 16, and that's 9. And if I divide that into 10 pieces, that's 0.9. So if I think about going up in 0.9s, and you could do this the same way, right? So if I did 4.5, I would need to go 5 lots of 0.9, which is 4.5, above the 16. And that gets me the 20.5 that I got to in the previous example. So here I'm just going to go up one of those. So 16 plus the 0.9 is 17, about. So it's 16.9, of course, but it's approximately 17. So that's what I'll say 4.1 squared is, about 17. 4.8 squared is 0.2 down from 5. So 2 of those is 1.8. So let's say we subtract 2 from 25. So that'd be about 23. 4.8 squared is about 23. Okay, so let's use that similar kind of logic on the next one. So 6.3 squared, we reckon will be between 6 squared, which is 36, and 7 squared, which is 49. So if I work out the gap, 49 take away 36 is 13, and then divide that by 10, so 1.3. I'm 3 intervals along. Okay, 6.3 squared. So 3 lots of 1.3 is 3.9, so about 4. So if I added on 4 onto this, I would get 40. So I'd say it's about 40. Okay, I mean, you could say, well, 1.3 times 3 is the 3.9, and we know that's going to be an overestimate. So maybe it's more like 39. Okay, so you could say that as well. But 39, 40, somewhere around that ballpark. Now what about 8.9 squared? So somewhere between 8 squared, so 64, and 9 squared, which is 81. So 81 take away 64 would be 17. So 17 divided by 10 is 1.7. So we're 1 interval down at 8.9 from 9. So 1.7 is about 2. So 2 down from 81. So let's say it's about 79. Okay? And so that is how I can estimate squaring a value like this.